Good morning, everybody. Today we will discuss the cargo topic liquefied tankers, liquefied gas. So, tanker safety for the operations that we will have in liquefied gas tankers or LPG ships or LNG ships as they are called. These are the modern type of vessels that carry LPG or LNG, that is liquefied petroleum gas or liquefied natural gas from the production areas to the consumer areas. The production of liquefied petroleum gas or LNG in the Middle East is basically in Qatar, which is the world's has the largest resource of LPG LNG. And from here it is taken into consumer countries like India, China, Japan, etc. etc. Today we will discuss the cargo operations on a liquefied LPG or an LNG ship's cargo cycle. So this chapter outlines the range of cargo operations normally encountered on a liquefied gas carrier and the general safety precautions to be observed in connection with these operations. So all the safety, LPG, LNG are the most dangerous types of vessels to be working on. So you have to follow all the safety precautions in absolute terms. It is not just for reading and forgetting. We have to implement every one bit of it because the dangers are immense. The procedures outlined should be considered as general guidance only. There is considerable variation in the design of the cargo containment and cargo handling systems, and specific instructions should be prepared for the inclusion of the cargo operations in manuals for individual ships. So every ship should have an individual cargo manual. These instructions should be carefully studied by all the personnel involved in the cargo handling operations. Although the cargo containment and handling systems have been carefully designed and have been constructed under strict supervision, the required levels of safety in cargo operations can only be achieved if all parts of the system and equipment are maintained in good order. Now, these ships are very costly. They are almost double the cost of a normal bulk carrier or a normal tanker. The reason being, there are so many equipment, so many parts of this thing to be able to be used in this carrying these cargoes. In such times, a lot of safety is also involved. And as they say here, all the cargo containment and handling systems have been designed carefully, but we make sure that they are maintained properly at all times. Every voyage, before the ship goes to load cargo, everything must be checked to make sure that they are in good working order. Similarly, the personnel involved in cargo operations must be fully aware of their duties and thoroughly trained in the correct procedures and handling of the equipment. Training in emergency procedures in particular is very important. Now, the first one is responsibility. Of course, the responsibility lies with the master, and it's the responsibility of the master to ensure that the officers and crew are properly and correctly informed of their duties and understand how to fulfill it. Now, the commissioning of the cargo system. Before a new ship is commissioned to carry liquefied gas, it is essential that all parts of the cargo system are clean and dry. As you know, we carry cargoes in temperatures that are below freezing. So it is very, very essential that all parts of the cargo system are clean and dry to prevent faults or damages, and that safety equipment have been checked and tested. After dry docking or repairs, cargo tanks should be cleaned and inspected at all levels to ensure that accumulations of rust, water, and possible loose objects have been removed. Internal fittings must be checked for tightness. And security of nuts and bolts will preferably have been spot welded. Manholes should be checked for the correct type of gaskets and possible damage. Covers should be properly tightened down. All the manholes must have their gaskets in place. The gaskets must be continuous, they must not be damaged, and they must all be screwed down tightly. It is essential that pipelines, valves, and pumps are carefully dried out. Piping systems should be thoroughly blown to with adequate quantities of compressed air followed by nitrogen, making full use of the drains in the system in proper sequence. Special attention should be paid to the body cavities of valves and to the convulsions of the expansion bellows. Now we'll see why this is shown here. General operations of cargo systems. The emergency shutdown system and the operation of all actuator valves, compressor and pump controls, etc. should be checked. Final adjustment and testing of some cargo plant control equipment can only be carried out with the cargo on board. Sometimes you can carry some tests only with the cargo on board. So those tests should be done that time. arrangements should be made in advance with the shore installation to allow this work to be carried out by the competent personnel during the early stages of the first loading. Pipe supports should be checked, especially where expansion bellows are fitted. Now the expansion bellows will expand and contract, so below them there will be pipe supports. You should make sure that they are all not damaged. Now the general cycle of cargo operations, every liquefied gas carrier must have procedures and arrangement manual which gives specific operating instructions. The following sequence outlines the general cycle of operations and supplementary comments are made where relevant. So you have the first is preparation for cargo transfer, then you have inerting and purging, then a pull down, loading, cargo conditioning, discharging, changing cargoes, and gas stream. So that's complete cycle on a gas carrier. So let us look at all this one by one. The preparation for cargo transfer, that's the first process. Before cargo transfer starts, the responsible officer should be satisfied that the precautions are being observed. The use of safety checklists appropriately adopted for the specific ship is strongly recommended. So, following things must be made checks before. The deck lighting is adequate, is working to provide safe working conditions. Ventilating systems are in operation as necessary. Fixed gas detection systems are calibrated for the cargo concerned and in operation. Fire protection equipment has been tested and is ready for immediate use, including water spray. Now, the fixed gas systems, because there's a gas leak or the concentration of the gas in any compartment, any place, they must be reading correctly. So they have to be calibrated from time to time, and you must check that for the concerned cargo that you are carrying, it's been calibrated, not for any material. Personal protection equipment has to be checked, and breathing apparatus bottles are fully charged. Protective clothing and breathing apparatuses are being worn or immediately available as necessary. So people must either be wearing them or must be readily available. No unauthorized work is being done in the cargo area, and non-essential personnel are being kept away from the cargo area. So that we should not have people or visitors in the cargo area unnecessary. Restricted liquid level gauges are secured in the closed position if their use is not permitted with the cargo. So in case you have liquid level gauges and they are not being used, they must be secured in the closed position. Adjustable relief valves are correctly set if multi-point relief valves are fitted. Flame screens or similar devices in the venting system are clear. It should be clear. It should not restrict the gas flow through it, or it should not be torn or damaged. Will not restrict gas flow and are suitable for the product. The oxygen content is below the specified minimum level in spaces required to be kept inerted, and a supply of inert gas is available to maintain a slightly positive pressure. Now, once we have done that, once we have checked all the compartments, the next step to do is inerting and purging. The term inerting generally refers to the replacement of air or cargo vapor by inert gas before loading or gas stream, respectively, to prevent the formation of flammable mixtures. The term purging, inerting and purging are slightly different. The term purging generally refers to the introduction of a suitable cargo vapor to displace an existing tank atmosphere. The extent of purging and vapors used will normally be laid down by the IMO codes or shippers' requirements. Shippers also should always be concerned about the atmosphere required on arrival at the loading port. Inerting or purging operations will take place at sea if the ship is suitably equipped or in harbor. In either cases, due consideration should be given to the safety of venting cargo vapor in the atmosphere, and any local regulations must be observed. Now, many ports in the world will not allow us to vent cargo vapors into the atmosphere. So you will have to have a vapor return line fitted to your cargo manifold, and these vapors will be sent ashore into shore receptacles. Venting is not normally permitted in port. If venting is unavoidable, operations should be carefully controlled to prevent dangerous vapor concentrations in the vicinity of the ship. Facilities may, however, be available for venting vapor to shore flare facilities. So what happens when you vent into the air? This gas is heavier than air, so it tends to settle down on the deck. So you are creating a very dangerous environment around your vessel and on the jetty. During inerting or purging, the relevant gas concentration should be monitored regularly at different tank levels to ensure safe concentrations. This is particularly important in tanks with internal structures, wash bulkheads, etc. Tanks can be inerted or purged separately or in parallel or in series according to the arrangement of the system. If tanks are inerted or purged in parallel, back pressure effects in the line may cause an uneven vapor supply to each tank unless the vapor supply to each tank can be accurately measured or controlled. Ship generated inert gas produced by combustion will contain up to 15% carbon dioxide and is unsuitable in certain circumstances. Such inert gas should not be used before loading a cargo with a temperature below -55°C because at such temperatures the CO2 will freeze and may contaminate the cargo. So the CO2 can also react with ammonia to produce carbonates which shall be deposited on the tank walls and may block the pipelines, etc. To prevent reaction, for instance, when preparing to load ammonia after carrying LPG, the inerted tank should be ventilated with air before ammonia is loaded, and when preparing to load LPG after carrying ammonia, the ammonia concentration should be reduced to 100 ppm by gas feed with air before inerting. Now, as you can see, inert gas generally a boon on all oil tankers. In LPG, in certain cases, it's a problem because inert gas contains 15% of carbon dioxide. Now, carbon dioxide can also freeze and collect on the sides of the wall or of the tank or inside the pipelines and can choke it out. That's the reason you need to purge the tank completely of inert gas with the cargo vapors if you're loading particular cargos such as ammonia. Inerting. The purpose of inerting is to prevent the formation of explosive vapors or air mixtures. The production of inert gas is outlined in the paragraph, and the gas used for inerting should be suitable for the purpose required. When inerting a tank which has been ventilated with air, the O2 content, oxygen content should be checked regularly. The oxygen content after inerting should never exceed 5% by volume and should normally be in the order of 2% to allow for uneven distribution. Now, you might have spaces in the tank where it reads 5%, some space in the tank where it could read 7-8%. That is why we ensure that it goes down below 2%, so that in any case, any corner of the tank you will not have oxygen more than 5%. Much lower levels of oxygen may be required for oxygen reactive cargos such as butadiene. The dew point temperature for the particular cargo to be loaded must be achieved during this operation. So if you're going to load specially oxygen reactive cargos as butadiene, your O2 content must be much lower than even 2%, maybe 0%. When inerting the tank which contains cargo vapor, the process should be continued unless the cargo vapor concentration is sufficiently low to prevent formation of flammable mixtures during subsequent ventilation with air. For further information on oxygen and cargo vapor content, you should see the relevant data. Now, each cargo will have data sheets. Relevant data sheet you should refer to find what is the level we need to inert or for purging. To avoid possible backflow of cargo vapor, the cargo line should be opened to the vent systems before the inert gas system is connected. It is advisable to use hot gas or some other suitable method to warm up the tanks that have contained low temperature cargos before inerting, so that the steel temperature is above the dew point temperature. Suppose you have carried cargos that are very cold, below freezing temperatures. It is better to put some hot air into the tank so that the tank structurals and sides and the pipelines can get heated to ambient temperature, or at least above the dew point. Failure to do so means that the larger quantities of inert gas will be required and moisture or carbon monoxide will freeze out. Similarly, if cold nitrogen vapor is introduced by inerting, atmospheric moisture is likely to be deposited in the tanks. So these are the precautions we need to follow while we are inerting on a LPG or an LNG vessel. Purging. The purpose of purging is to prepare the tanks for receiving the cargo. Normal shipboard inert gas may have to be displaced with pure nitrogen for cargo requirements. For example, to remove carbon dioxide or to obtain a low dew point. Neither inert gas nor nitrogen can be condensed by the ship's re-liquefaction plant. So the ship's re-liquefaction plant cannot condense your nitrogen or inert gas. So purging with cargo vapor is therefore necessary. In this case, you need to get the cargo that you're going to load, vapor from that cargo itself to purge your tank and take out all the nitrogen or the inert gas that is present now. Cargo vapor for purging can be taken from a shipboard storage vessel via a vaporizer and the cargo vapor inert gas mixture vented to the atmosphere. When purging with cargo vapor input, the cargo vapor inert gas or nitrogen mixture should be led to a proper vent or a flare stack ashore for safe disposal. Purging is completed when analysis of vapor samples from the vapor samples from the tanks are satisfactory, or when inert gas concentration is sufficiently low for the reliquefaction plant to operate continuously, or both. Method of inerting and purging. One of the three methods may be stratification displacement method. So different strata are formed, or turbulence or dilation mixture method, or the vacuum pressure method. This vacuum pressure method is not used nowadays. It's an uncommon procedure. It can result in a total low pressure shutdown, making a renewed startup a very complex process. So this is generally not used nowadays. Now we go to the next step, that is preparation for loading, including cool down the tanks. Now you have your tanks at ambient temperature, the tanks, the pipelines, the pumpings, all the LNG systems. They must be cooled to ambient temperature. Otherwise, if you're going to inject a cargo of say minus 50 degrees or minus 60 degrees into the tank straight away, which is at ambient temperature, you can have fractures and cracks in the metal, and you will have ruptures in the tanks. So after tank has been inerted or purged as necessary, it has to be carefully and directly prepared for loading in order to prevent uncontrolled pressure rise and unsafe temperature gradients developing during the initial stages of loading. Most cargoes have sub-zero boiling points at atmospheric pressure. Butane is minus 5 degrees, ammonia is minus 33 degrees, propane is minus 42 degrees, ethylene is minus 104 degrees, and methane is minus 163 degrees. So these are the temperatures that these cargoes are generally loaded and transported across. These boiling points are correspondingly higher at higher pressures. Cargo liquid entering cargo tanks or pipings which are at ambient temperature and pressure will therefore immediately begin to boil, and its temperature will correspond to the boiling point at atmospheric pressure. Boiling and evaporation will result from heat transfer into the liquid until the structure reaches the liquid temperature. This initial boiling will cause a rapid pressure rise in the cargo system. The pressure attained will depend on the quantity of liquid, the heat available for evaporation, and the capacity of the vapor return time on the vent stack. The ship's reliquefaction plant cannot condense the vapor until very nearly all of the incondensable inert gas has been removed. If the rate of vapor generation exceeds the vapor return capacity, pressure in the tank will increase quickly and it will exceed the release valve setting, causing venting through the vent mast. So care should therefore be taken to introduce cargo liquid into warm cargo tanks sufficiently slowly to avoid an alarming pressure rise and uncontrolled venting. The initial boiling will also cause local cooling of the tank structure, resulting in thermal stresses. Great care should therefore be taken during cargo operations to avoid undue thermal stress or shock, particularly in the case of low boil point cargoes. Not only is it danger, it also damages your vessel or the pressure vessel in which you're loading cargo. Cool down. Now, cool down of tanks and pipelines is undertaken to control thermal stresses, and loading rates should be restricted during cooling down. During cool down, the loading rate is at the barest minimum possible. During cool down, valves should be opened frequently to ensure that they are free. Where practicable, pump shafts should be turned manually at intervals. LPG from pressure storage at above 0 degrees C may contain water. If used for cool down before loading LPG, ice or hydrates can form where expansion occurs. Water can be prevented from freezing by dosing it with antifreeze. But antifreeze can only be used after consulting the shipper because it could be inimical or dangerous for the cargo that we are loading. Minimum cargo tank. Some cargo tanks, such as fully pressurized tanks or semi-pressurized tanks, have a minimum allowed cargo temperature which is higher than the boiling point of 1 degree or R, more than the products which the ship is certified to carry. In order to avoid cooling such tanks below their limit during loading, they must be pressurized until the corresponding liquid temperature is above the minimum pressure, permissible tank temperature. On completion of discharge, any remaining liquid must be thoroughly stripped before cargo loading. Before cargo is loaded, a pre-arrival ship and shore checklist is done. Now we have done the checklist when we did oil tankers. So there's a similar ship shore safety checklist to be followed. In this case, there are slightly different items are there. During loading, cargo is transferred from shore Loading must not commence until information on the cargo has been obtained. During loading, cargo is transferred from the shore to the appropriate midship or stern manifolds and led into the cargo tanks via the filling machines. As the liquid level rises, the tank pressure will increase by vapor pressure of the warm cargo, vapor displaced by the incoming liquid, vapor generated by heat transfer to the tank walls to the liquid, and vapor generated by heat transfer from the ship and shore pipelines and the shore pumps. On fully or semi-pressurized ships, the vapor pressure increase during loading can be reduced by spray loading, provided the cargo temperature will leave a saturation pressure safely below the relief valve set pressure. With fully or semi-pressurized tanks, the boil off and displaced vapor is either returned to shore or condensed by the ship's re-liquefaction plant. Venting during loading must be avoided. In the case of LNG, the boil off cannot normally be condensed and the ship will be dependent on a full vapor return to the shore. The responsible officer should ensure the following precautions are carried out and should those set out. In the event of emergency, the emergency shutdown procedure must be implemented. AH6 detection equipment should be operated throughout the loading operations. During the early stages of loading, the incoming liquid may be relatively warm and generate quantities of vapor in excess of capacity of the re-liquefaction plant or vapor return tanks. So the tank pressures should be carefully monitored at all times. During the early stages of loading, the incoming liquid will be relatively warm and generate quantities of vapor in excess of the capacity of the re-liquefaction plant. The tank pressure should be regularly observed during loading and the loading rate to be reduced in good time before approaching safety valve set pressures. If reducing the loading rate does not reduce the pressure rise, the loading should be stopped immediately and the terminal should be notified to enable proper steps to be taken in the event of hazard to the adjacent shore areas. If venting occurs, it will cause self-refrigeration, thus reducing the cargo temperature and pressure. Percentage filling of cargo tanks may cause significant loss of pressure in the hold or inter-barrier spaces, depending upon the cargo system design. This should be continuously monitored and pressure maintained by the addition of supplementary inert gas, dry air or dry nitrogen. Filling limit regulations should be observed. On completion of loading, all ship lines should be drained into the cargo tank using the facilities provided. Liquid in hoses or loading arms should also be drained to the cargo tanks if possible, or blown to the shore and pressed past shore valves by vapor pressure. If possible, the ship's fuel connection should be purged before being disconnected. Ship's fuel connection should not be broken until it has been ascertained that all liquid has been removed and the lines are depressurized. Adjacent isolating valves on the ship and shore or any of the relevant valves should be closed before connections are broken. Bonding wires, if fitted, should not be disconnected until after the hoses have been disconnected. The release valves of some ships have dual and multiple settings, either for operational purposes or to meet differences in national regulations. Now, cargo conditioning. The term cargo conditioning refers to the care and attention to be given to the cargo during the passage from the loading port to the discharging port. We should ensure that there are no undue losses in cargo quantity. Cargo tank pressures are kept within design limits, and cargo temperature is maintained or adjusted as required. These aims are achieved either by re-liquefaction or in most LNG ships by using the boil off as propulsion fuel. Now, the LNG ship is the only ship where we can use the cargo as fuel to fuel the main engines of the ship. So, the boil off is used as a propulsion fuel. Cargo conditioning may not be necessary on ships with pressure vessel tanks. If re-liquefaction plant is fitted, the responsible personnel should have a thorough understanding of its operational principles. When running, the plant should be monitored so that anything which might adversely affect its safety or efficiency is quickly recognized and corrective action is taken. The plant is normally fitted with shutdown devices, sense high liquid level, temperature and pressure. Re-liquefaction and boil-off control. General guidance on safe procedures for re-liquefaction and boil-off control is given below. The detailed instruction for any ship depends on the system fitted and the manufacturer's operating instructions should be followed. There are several different types of re-liquefaction systems and these are discussed. The most common involves compressing the cargo vapor and condensing it in a seawater cooled condenser. Alternately, the condenser may be cooled by a refrigerant from a secondary refrigerating unit, which is called a cascade type refrigeration. Another type of re-liquefaction is achieved by circulating the refrigerant through coils inside the tank or through a separate heat exchanger outside the tank, which is called indirect cooling. Cargo incompatible refrigerants should not be used, nor refrigerants which are known to have a high ozone depleting potential. The vapor of certain cargoes, such as ethylene oxide, propylene oxide, etc., cannot be compressed. Such cargoes can only be refrigerated by indirect cooling, and cargo compressors usually have to be isolated or banked off. LPG is normally re-liquefied by direct compression and condensation in one of two stages, with condensation against water in what is called a direct re-liquefaction system. Colder cargoes such as ethylene, although still require direct compression, require a cascade system with the cargo condensing against a secondary refrigerant, which is condensed using water as a coolant. We'll continue this in the next class for looking at the discharge cycle and for the preparation for the next cargo. Thank you.